In today's lesson, we'll be learning about common factoring. In a previous lesson, we learned about the distributive property. The distributive property is used to expand. We expanded expressions like this into expressions like this. The opposite of expanding is factoring. You can factor an expression like this into an expression like this. As you can see, expanding goes one way while factoring goes the other way. If you remember, expanded involved using the product rule, where coefficients were multiplied, bases stayed the same, and exponents were added. Since factoring is the opposite of expanding, instead of using the product rule, you will be using the quotient rule, where coefficients are divided, bases stay the same, and exponents are subtracted. In our first example, we want to factor this expression, 4x plus 10. Factoring involves several steps. The first step is to find the greatest common factor of the coefficients. The coefficient here is 4, and the coefficient here is positive 10. I want you to try to think of the largest number that can divide evenly into the numbers 4 and 10. That is what a greatest common factor is. The greatest common factor here would be the number 2. The next step is to look for a common variable with the lowest exponent. This term has a variable of x. This term does not have any variable. Therefore, they don't have anything in common. The last step is to find the combined common factor, which basically involves combining what you have in this box and what you have in this box. So when you combine those two things, all you have is the number 2. We're going to take this combined common factor and place it right over here. You want to put the original expression in brackets. You're then going to divide everything in that original expression by your combined common factor, which was 2. This 2 in front of the bracket is going to stay exactly the same. We now want to use our quotient rule for everything inside the brackets. The first step of the quotient rule is to look at the coefficients. The coefficient here would be 4, and the coefficient here would be 2. You want to divide coefficients. So 4 divided by 2 is going to give you 2. Next, you want to take a look at the bases. This has a base of x. This does not have a base. Bases stay the same. So that x is going to stay x. And last, you want to take a look at the exponents. There is no exponent here, which means there's a hidden 1. And there is no exponent here because there is no base. So you can just leave this without a exponent down below. Next, you don't really need to use the quotient rule here because positive 10 divided by 2 is going to be equal to positive 5, and you should add in a plus sign in between. You can always use the distributive property to check your work. If you come up with your original expression, that means you have factored correctly. In our second example, we want to factor this expression, 10x to the power of 2 plus 15x plus 20. Factoring involves several steps. The first step is to find the greatest common factor of the coefficients. The coefficient here is 10, the coefficient here is positive 15, and the coefficient here is positive 20. You want to think of the largest number that can divide evenly into 10, 15, and 20. Therefore, the greatest common factor here would be the number 5. Next, you want to find the common variable with the lowest exponent. This term has a variable of x. This term has a variable of x as well. However, this term has no variable. Therefore, these three terms have nothing in common. Last, you want to find the combined common factor, which basically involves combining what you have in this box with what you have in this box. So when you combine those two things, you just end up with the number 5. That combined common factor you just found is going to go right over here. And the original expression stays unchanged. You want to put it in brackets. You now want to divide everything in that original expression, which is in brackets, by the combined common factor. So that gets divided by 5, this gets divided by 5, and this gets divided by 5. The 5 in front of the brackets is going to stay the same. And at this point, you want to use the quotient rule, which means first take a look at the coefficients. That's 10, and this is 5. You want to divide them. So 10 divided by 5 gives you the number 2. Next, you want to take a look at the bases. There's a base of x here, and there is no base down there. Therefore, the base is going to stay the same. And last, you want to take a look at the exponents. There's an exponent of 2 here, and there is no exponent here because there is no base. You want to subtract exponents, so 2 subtract nothing is just going to stay the same. We're going to repeat this process again. So over here, the coefficient here is 15, and that is 5. Coefficients get divided. So 15 divided by 5 is going to give you positive 3, and you should add a positive sign on your own. Next, take a look at the bases. The base here is a variable of x, and there is no base down there. Bases stay the same, so that's going to stay x. Last, you want to take a look at exponents. There is no exponent up here, but there's actually a hidden 1. And down here, there is no exponent here since there is no base. I'm not going to rewrite that hidden 1 below in my 3x, so we can just leave it like that. And last, we don't even need to use a quotient rule here because we have positive 20 divided by 5. And that is going to be equal to positive 4, and you need to add a plus sign in front. Now, you can always check your answer by using the distributive property and working backwards. If you end up with this expression, that means you factored correctly.